F-35 like this one takes about 4 years to make from order to delivery.
The number of airplanes in the field is growing exponentially, over 200 now, and there'll be many, many more going as we increase their production and ramp here.
Modern fighter jets are not limited by missiles or pilots. They are limited by maintenance, and that maintenance is controlled by a network most countries do not own. This is the maintenance network that keeps fighter jets flying. And who controls it? The F-35 Lightning II is the most advanced fighter jet in the world. Stealth, sensors, full data integration. It represents everything modern air power is supposed to be. But it is not a finished product. It degrades from the moment it leaves the ground. Engines wear down. Stealth coatings crack. Avionics need updates. Components reach the end of their service life and must be replaced. Every flight hour pushes the aircraft closer to its next maintenance window. A fighter jet that cannot be maintained cannot fly. Maintenance is not a mechanic in a hangar. It is a system. And that system has 3 layers. Each one is a point where control can be lost. The first layer is facilities. Maintaining a 5th-generation fighter requires specialized tools, certified technicians, and controlled environments. Stealth coatings cannot be repaired in an open hangar. Engine servicing requires equipment that most air forces do not operate independently. Structural repairs demand certified components handled by qualified crews working inside facilities built to exact specifications. If a country does not have those facilities, the work cannot be done locally. The aircraft has to be sent somewhere else. Time is lost before the jet even returns to service. In a conflict, time is combat capability, and it is gone. The second layer is parts. A single fighter jet contains tens of thousands of individual components. Every one of them has a defined service life. When something wears out or fails, it must be replaced with a certified part that meets exact specifications. That part does not arrive instantly. It is ordered, approved, processed, shipped, and cleared through export controls before it ever reaches the base. Each step in that chain adds delay. Each delay reduces readiness, and when multiple components fail at the same time, those delays stack. A jet waiting on 3 separate parts is a jet that is not flying. A jet that is not flying is a gap in defense coverage. The third layer is software and diagnostics. This is where the modern fighter program departs most sharply from everything that came before it. The F-35 operates inside a centralized digital ecosystem that tracks component status, schedules maintenance, manages mission data files, and distributes software updates across every aircraft in the global fleet. That ecosystem runs through infrastructure that the operator nation does not own and does not fully control. If diagnostics depend on external systems, the operator cannot independently assess the aircraft's condition. If updates are delayed, capability is delayed. If the system stops, the aircraft stops. If that connection is disrupted, the operator is left without the tools to keep it running. Maintenance is a system, not a task, and the system is not owned by the countries flying the jets, which brings the conversation to where the power actually sits. Pratt & Whitney controls the engine. Lockheed Martin controls the system. There is no alternative supplier for the F-135 power plant. There is no parallel logistics platform an operator can switch to. There is no independent workaround for software modifications or weapons integration. Every path leads back to the same controller. If a country wants to modify a system, it requires approval. If it wants to integrate a new weapon, it requires approval. If it wants to update mission software, that update arrives on a schedule determined elsewhere. The operator does not set that schedule. The operator waits for it. If the system slows down, the operator cannot bypass it. There is no secondary option. There is no independent path forward. There is only the wait. Who controls maintenance controls readiness. That is the core of this entire conversation. Not the range of the aircraft, not the power of its radar, not the sophistication of its stealth shaping. Readiness is determined by the maintenance network. And the maintenance network is controlled by someone other than the country that paid for the jet. This is not abstract. It shows up in availability rates. It shows up in mission-capable percentages that fall well below what was promised at the time of purchase. It shows up in fleets that are technically owned by sovereign governments, but operationally dependent on decisions made in offices they have no access to. The aircraft carries a national roundel. The system that decides when it flies does not. Now consider what that dependency looks like in practice. In a stable environment, none of this is visible. Political relationships are cooperative. Supply chains flow without disruption. Parts arrive within acceptable time frames. Software updates roll out on schedule. The system works, and the operator has little reason to question the architecture underneath it. But stability does not last. Trade disputes introduce friction. Tariff threats change the tone of conversations that were previously routine. Diplomatic pressure reshapes priorities inside the organizations that manage parts supply and software access. And suddenly, the dependency that was invisible becomes impossible to ignore. Approvals that once moved quickly begin to slow. Parts that previously arrived on schedule begin to queue. Updates that were expected begin to wait. The aircraft has not changed. The threat has not changed. But the system that keeps the aircraft flying is now moving at a different speed, and the operator has no lever to pull. Parts arrive late. Repairs wait on approvals. Software updates move on someone else's schedule. No parts, no repair, no flight, no control. That is not a worst-case scenario built for dramatic effect. It is the logical outcome of a dependency structure that was never designed to guarantee the operator's independence. It was designed to guarantee interoperability. Those two things are not the same, and that distinction is why the conversation is changing. Countries are not reconsidering their procurement decisions randomly. They are reacting to experience. They have seen the delays. They have read the readiness reports. They have felt the political pressure and understood what it revealed about the limits of the relationship they had assumed was unconditional. They want local maintenance capacity. They want domestic parts production. They want software they actually own and can modify without seeking permission. That is not an ideological position. It is a practical response to what the data has shown them. Some platforms were designed with exactly that requirement in mind. Sweden's Gripen is one of them. It was not designed to win a technology contest. It was designed for independence. Operators receive full software source code. Maintenance is built around field conditions and small crews. The aircraft can be serviced without a major infrastructure base, without contractor teams flying in, and without waiting on an external approval system. Countries that operate it control the system that keeps it flying. That is a fundamentally different proposition. And it is gaining attention precisely because the alternative has shown its limits. Countries evaluating that model are not just evaluating a jet. They are evaluating a relationship, and they are asking a question that was not being asked a decade ago. What does it actually mean to own an aircraft if someone else controls whether it can fly? This is not about maintenance, it is about control. A country can sign the contract. It can take delivery of the aircraft. It can train the pilots and build the runways and stand up the squadrons. And it can still find itself dependent on external decisions at the moment it needs to act most independently. Because ownership of the aircraft is not the same as control of the outcome. Control is not about who flies the jet. It is about who decides when it can fly. It is about who holds the key to the system that keeps it airborne. And in the current architecture of advanced fighter programs, that key is not held by the operator. It is held by the manufacturer, by the contractor network, and by the government that oversees the entire ecosystem from the top. That reality is now driving a shift that will reshape the fighter jet market for the next generation. More countries are demanding technology transfer as a non-negotiable condition of purchase. More governments are insisting on domestic production arrangements that give them real industrial capacity rather than final assembly of components manufactured elsewhere. More procurement evaluations are weighting maintenance sovereignty alongside performance specifications. This creates a new problem for the existing model. More local systems mean more parallel supply chains. More parallel supply chains mean less shared logistics efficiency. Less shared logistics means higher costs and greater coordination complexity. The unified platform model that made the F-35 program strategically attractive was built on an assumption of permanent political alignment and frictionless industrial cooperation. That assumption is being tested, and in some relationships, it is failing. Air power is becoming a logistics problem, not just a military one. The countries best positioned for the next conflict are not the ones with the most advanced aircraft. They are those with the most resilient maintenance networks. Networks they actually control. Networks that do not depend on the cooperation of a partner whose interests may shift. Networks that keep flying when supply chains are under pressure, when diplomatic relationships are strained, and when the system that everyone assumed would run forever begins to show its limits. The aircraft that wins the next war will not be the most advanced. It will be the one that keeps flying when others cannot. Modern air power is not decided in the sky. It is decided in the maintenance network on the ground. If this is the kind of analysis you want more of, make sure you are subscribed so you do not miss what comes next.